In this video, you will learn the basics of TypeScript from JavaScript code. We will cover what is TypeScript, static typing, types by inference, defining types, and more. Let's get started. Hello there. Now, what is TypeScript? TypeScript is an extension of JavaScript, but with static typing support. So, we're on TypeScript Playground right now, and this video is going to go over these docs, but simplify it a bit. This video is specifically for going from TypeScript, or JavaScript, sorry, to TypeScript, and it will help with that. So, what is going on here? Well, we're using TypeScript, and this is outputting the JavaScript it transpiles into. So transpile means convert from one language into another. Technically, it is another language, but it's more of an extension of JavaScript. This is what it looks like in JavaScript, so it's using strict mode by default. So, static typing. What is static typing? Static typing is when the compiler knows what a variable is. So, what is a compiler? Well, a compiler is the thing, or the system that kind of converts the code into machine code, so binary basically. So it can be executed by a machine. Static typing is when the compiler knows what type of variable is. If there is a problem with the type, it's not going to compile. Now, in JavaScript, let's open JavaScript, Control-Shift-J, I believe. Okay, clear. So, if I type var test equals this, so TypeScript, the difference between this is if we set test to a number now, it's been a number and a string. So if we try to do the same thing with TypeScript, test equals 2, it's going to throw an error because it went from a string to a number. Now, it does it in JavaScript, but not with TypeScript. It likes to stick with one variable type at a time, and this is called types by inference. So TS can guess the variable types whilst we write them. So if we make a number, let num equals 2. So what if we want to show TypeScript so it doesn't have to guess that it is a number? Let's set num to a string. See what happens. It's going to have an error. Let's say we want to restrict what types variables can be without TypeScript having to guess. So this is where defining types come into. So this throws an error because we changed our mind. We want the number to be a number at first, then we want it to be a string. TypeScript is like, nope, I'm not having that. We're going to do something else now. We're going to have a vector 2D, which is x and y coordinates. So we're going to have a number, and we're going to have another number. So an interface, it's like an object, but instead of having values in there, the values are types. So key value, which is a type. So let's define a vector. So vector 2D. So now what do we put in here? Because we're declaring it explicitly that it's a vector 2D, we have to define x and y as a number. So if I type y as a string, what's going to happen? String is not assignable to type number, which is declared here. So this needs to be a number, and everyone's happy. What if I have a z? So it can be a 3D vector, so z is used for another dimension really. So now we'll just call it vector this time, because it can be 3D or 2D. So z is optional if it's a 2D or 3D one. So it has x, y, and z coordinates. So this is also a number, but it's optional. So it can, if it doesn't have the number here, if it doesn't have the z number, it's a vector 2D. If it has a number, it can and cannot. It doesn't have to have one because if we declared it as optional. Now this pipe we'll get onto in a minute. It means it can be either of these types. What are shapes? Well, we're going to have a function here called getPoint. We're going to have a function called getPoint, and it takes in a vector. And then we define, in this way, we do this, and we define the type here. So if we want it to be optional, we put a question mark, or we just define the default value here, like that. And that will work too. Then we make a function out of it. Console.log, should we log this? Yep. So we can type vector.x, vector.y. And that's going to print off 0, 0. Or just 0 space 0, because we're not printing the comma. So let's print the comma with template strings. There we go. So what is going to happen? Obviously it's going to throw an error, so it's not going to work. So, no logs, it says. So we press run, and then it transpiles. Does it work? No, because we're not actually calling this. So getPoint. Now, the problem is, if we type 22 or something random, it only takes in one argument. So we actually put in the vector x equals 1 and x equals 2, y equals 2, sorry. So this is kind of a 2D vector. Now run, and we get 1 and 2. We can also have vector z. So z, we don't even need to declare z, and it will be 2. Let me show you that. Undefined, hold on. Why is this undefined? Because we overwrote this and declared this instead. So we can pass in z here. So if there's nothing there, then it will run. It will use this. Let me show that. It will log that instead. There we go. That is shapes and return values. Let's get on to return values. We wouldn't want to return this because, well, we're not returning anything right now. We're just logging it. So let's return. Now, what is going to be inferred when we return this? It's a string, because this is a string here. That's why it's a string. We can also declare number, but it's not actually returning a number here. It's a string, and it throws an error. So we type string. We can also do this, and it explicitly knows it's a string. Once we tell it it's a string, that's explicit. Now it's implicit, it has to guess that it's a string, but it does the same thing. And that is return values right there. So we'll just log getPoint, and the same thing is just going to happen. There we go. Now let's get on to something else, which is composing types. So we can join types together. So let's join types together. So I said up here, number. A number cannot also be a string, but what if we want a number and a string? Number and string. So number and string can be a number and string. So this time it's 2 or something. So here it's a number, and it also can be a string. So if we just get rid of string, it's going to throw this error here. But now it can be both, because this is a union type. It joins the types together, so it can be either of these, number or string. Let's recreate this before we get onto generics. So vector 2D, and we have vector 3D. So this is a bit better. So we're going to write another way of declaring this, vector 2D or 3D. So we can have a 2D or a 3D, and we declare it the same thing here. So vector or vector 3D, vector 2D or 3D. There we go, and then we pass it in here. So it can be either. So what is that? Both. Now Z does not exist on vector 2D because it's declared as a vector 2D here, not a vector 3D. So if we add Z here, now it will go away, because now it's inferred as a vector 2D instead of a vector 3D instead of a vector 2D. There we go. Now, generics. What is a generic function? Let's make an array class, actually. Instead of a function, you can also do a functions array. Is this reserved? Oh, it is reserved. It's already used. My array you could use. So, my array has... Now, arrays can be set as any types. So, array string can only contain strings, let's call it. Array string equals. Now, this is only allowed to contain strings. And hold on, let me make this a type annotation. Test. So if we put a number here, so we have two tests. If we put a number, it complains because only strings are allowed. Similarly, numbers here, we can call this numbers. These two will throw an error because only numbers are allowed. So how we declare a class like this, we put T here. We restrict the types that can be put in here. But that's how you declare it, and T can be used within the class. Let's have a demonstration. Constructor T. There we go. And a thing with TypeScript is you can actually, instead of having to type this.t equals T passed in, now T doesn't exist yet because we need to actually declare one, a T, up here, and then it will go. But we can shorten this. We can type private T equals that, and what private means is it can only be accessed within this class and nowhere else. So let's demonstrate that. This.t, now it's declared here and it's automatically set and done for us. So log T or get T, let's just get T, return this.t. So let's make a new array here. So const equals new my array. Okay, so we pass in the type, which is, what is the type? We're going to restrict it to, so string. So we're going to have an array of strings here. Now we need to pass in the T. Now we can make this optional here, but that's up to you. So in an array, you really pass in the initial values instead of having to push them manually, but let's pass in something. Okay, so get T just returns T. This is not much to do with an array. It's just an example here. So my class would be better. So now, let's try get T. Now, T, if we look at T, it's unavailable. This.t is available only within the class. This is an access modifier, so console.log get T. Now, what do you think is going to happen? It's gonna log something, isn't it? Because something is originally passed in, it's set here, and then we return it here and log it. Simple. So these both throw an error. Throws error. So, there we go. Now, we're nearly done. So, structural type system. If objects have the same shape, they're considered the same type. So, for example, let's use an example of a person. So a person has a name and an age, which is a number. Cool. So, const person, let's make a constant variable, name is Steve, age is 21. So there we go. Now person can also, so this, let's call it person 1, person 2 will be Dave, and 25. So person can also equal this, and it will be considered the same type because it has the same properties declared in this interface right here. Now this can also be done with a class. So let's use the example of an animal, because I always do that. So name. Now we don't, remember we can just have a constructor that does this, private name. You can also put public here, which means it's accessible outside of the class too, which is, it's public by default. Methods are public by default if you don't explicitly define that access modifier. So an access modifier restricts how you can access a method or property, so remember that. So public name, so we put it, you can define how it checks types in tsconfig, and how strict it is, but name implicitly has an any type, so we actually define a type here so it doesn't complain. We can also have type any, and that will ignore the TypeScript issues, but we can have string, and age, public age is a number, so I'm also gonna do this. Cool. That's it. So this animal has a name and age. Similar to a person actually. So as you can see, a person and an animal have the same properties. So let's make a person 3, that's also an animal. Confusing. Oh, that worked too. Let's have name 1 just to mess it up. Oh, okay, it's missing here. So why is it doing this? Because person has a name and an age, and animal has a name and an age. If I make this a string, it's going to complain. So this is considered the same as this, because it has the same shape, and this shape is what types it has on the object. There we go. That was TypeScript very quickly. Hopefully you understand a bit more. And let's do a recap. If you originally declare a number or a variable, a number in this case, to 2, it cannot be a string unless you declare here string or number. Then it can be a string or a number, or boolean if you want. Then it can also be a boolean. Okay, interfaces declare the shape of an object. So a shape is what types it has. So this also returns, we define what it returns implicitly. It knows it returns a string. The compiler knows it returns a string, this method here. And then we log it. Cool, and then we get more advanced. So a string or a number, and it can be both, remember. Okay, vector 2D and 3D. So this here is equivalent to this. So we can replace that with this, and it should be the same. So vector 2D or 3D. So it can, so the Z here in this case is optional. If I remove that, the Z's an extra property. If I remove the 3D, so it doesn't like that. It needs to match the shape of the vector 2D. So we make a my class here. I don't know why I called it R. We started with an array. And then we log that. We log a private variable. And these two throw errors because it's restricting the array. Now an array is a built-in type. 2 strings and numbers here. There we go. So person, and also objects that have the same shape are considered to be of the same type. A person here is also an animal. So here we can have implements person. And we've already implemented person. We have an extra property called birthday or something, and it's a date. Oh. Now we need to implement public birthday as a date and pass it in, etc. There we go. That's TypeScript.